Assalamualaikum warahmatullahi wabarakatuh. My name is Nora Zaliza binti Muhammad Jamil. I come from Faculty of Industrial Sciences and Technology, UMP, University Malaysia Pahang. Okay, our course name is Calculus is a Piece of Cake. Okay. Now, I would like to discuss Chapter 3 in the Calculus course, which is Application of Differentiation. Okay, now, we're going to learn about 3.1, Rates of Change and Related Rates. Example 1. A spoon of oil is spilled on the surface of the water, forming a circle. The radius of the circle is increasing at a rate of 1.3 cm per second. How fast is the area is increasing when the radius has reached 2 cm? Okay, let's do this example. Okay, we see that the problem talk about oil is spilled on the surface of the water, forming a circle. So we have circle here. This is a circle. The radius of the circle is increasing at a rate of 1.3. So here, this is the radius. R for radius, and the rate for radius increasing, dr dt equal to 1.3 cm per second. Okay, that's the information from the problem. So the question is, how fast is the area is increasing? Area means dA dt equal to what when the radius is 2 centimeter. Okay. So now we can see the relation between area and the radius is A equal to pi A equal to pi r square. Okay, this is the formula for area of a circle. We want to find dA dt. By using chain rule, dA dt equal to dA dr multiply with dr dt. dA dr is, when we differentiate A with respect to r, we get 2 pi r, and dr dt is given in the question, which is 1.3. So, we compute this and insert r equal to 2. So 2 pi multiply with 2 multiply with 1.3, and you will get 5.2 pi centimeter square per second. So the answer is 5.2. Okay, 5.2 pi centimeter square per second. The area of the circle increasing at this rate. Okay, that's for example 1. Okay. Example 2. The question is, air is being deflated from a spherical balloon at the rate of 20 seconds cube per second. How fast is the radius of the balloon decreasing when the radius is 3 cm? Okay, we are talking about spherical balloon. Spherical, let's sketch the spherical balloons. Okay, we have balloon that is spherical. Air is being deflated. That means that the balloon is shrink at a rate of 20 cm cube per second. That means this is dV dt equal to minus 20 and the unit. Okay, negative means the volume is decreasing. Now the question asks, what is the radius, or how fast is the radius? So we need to find dr dt. Changing when, and the condition is when radius is 3 centimeter. So we need to find the dt. Okay, now first we have to determine the relation between V and R. What is the volume of a sphere? Volume of a sphere is V equal to 4 over 3 pi r cube. And from this we can find dV dr equal to dV dr equal to 4 pi r square. Okay, you know this, right? Now the question needs us to find dr dt. So we need to write the chain rule. dV dt equal to dV dr dr dt. Okay, dV dt is given negative 20. dV dr is 4 pi r square dr dt. From this equation we can find dr dt, and by putting r equal to 3 we can get dr dt equal to negative 5 over pi r, we substitute with 3 square, which is equal to negative 0.1768 centimeter per second. Okay, so this is the answer. The radius change with the rate of negative 0.1768. Example 3. Jessica poured water into a cylindrical cup that has a base of radius 3 cm at the rate of 2 centimeter cube per second. How fast is the height of the water rising? Okay, now in this question, the key point is cylindrical cup. So the geometry for cylinders like this. Okay, this is cylindrical cup. Maybe, okay, I redo that again. Okay, for this question, example 3, the key point is a cylinder. So let's sketch the cylinder. Okay, and it said that the radius of the cylinder is 3 centimeter. So the radius is 3 centimeter. And the rate is 2 centimeter cube per second. This is dV dt. dV dt equal to 2 cm cube per second. The question is how fast is the height of the radius, the height of the water. So we need to find dh dt equal to what? Okay. Now let's find the relation between the volume of a cylinder and the height of the cylinder. Okay, we know that V equal to, or the volume of the cylinder equal to pi r square h. Okay, we see that the radius is remain 3 all the times. That means we can substitute the radius equal to 3 here, which is equal to 9 pi h. Okay, now you have V equal to 9 pi h, so you can find dV dh, which is equal to 9 pi. Okay, the chain rule here is dV dt equal to dV dh dh dt. dV dh is given here, we calculated before, 9 pi. dh dt is the one that we want to find. So let's do like this. Okay, we delete this and we put dV dt here is given as 2. dV dh is 9 pi and dh dt the one that we want to find. So now dh dt equal to 2 over 9 pi, which is equal to 0.0707 centimeter per second. For example 4, a conical paper cup full of water has dimension of 2 centimeter for the radius and 8 centimeter for the height. The water is dripping out from the bottom of the cup at the rate of 3 centimeter cube per second. How fast is the height of the water in the cup decreasing when the water is exactly 4 centimeter deep? Okay, the key point here is cone, a conical paper cup. So let's sketch the cone. Okay, and the dimension is 2 cm for the radius. Okay, we have radius 2 cm and 8 cm for the height. So that means this is 8 cm. Another information is the water is dripping out from the bottom of the cup at the rate of 3 cm. What is this? This is dV dt equal to minus 3 centimeter cube per second. The question is how fast is the height of the water? So height is h, dh dt equal to what? S, and the condition when h is 4 centimeter. So look here, what is the relation between the volume of a cone and the height of the cone? Okay, we know that the formula for volume of a cone is V equal to 1/3 pi r square h. Okay, now we have two variables here, r and h. Okay, now we have to find what is r. R is not a constant. It is denoted by this relation or this ratio. R over h equal to given 2 and h is given as 8. So the relation here R is h over 4. Okay. Now we can put this relation back into the volume. So volume is 1/3 pi and r is h to the 4 square h. And you can calculate this equal to 1 over 12 pi h cubed. Okay, now we have the relation between V and H. From here we can find dV dH is equal to 1 over 4 pi h square. Simple, right? So we got this, and then the next step is by writing the chain rule. The chain rule here is dV dt equal to dV dH multiply with dH dt. Now dV dt is minus 3 equal to 1 over 4 pi h square multiply with dH dt. And after we do the calculation, we insert the value for h equal to 4, we get dH dt equal to negative 0.2387 centimeter per second. Example 5. The top of a 13-meter ladder is leaning against a wall. If the ladder slides down the wall at the rate of 4 meters per minute, how fast is the foot of the ladder moving on the ground at the instant when the top of the ladder is 5 meters above the ground? Okay, look at this question and take the important information. The top of a 13-meter ladder is leaning against a wall. So let's sketch the ladder. This is the wall. Okay, we can use and we have a ladder. Okay. If the ladder slides down the wall at the rate of 5 meters per minute. So what is 5 meters per minute? Okay, so we need to determine the dimension or the related variable. Okay, let's say this distance is represented by x. Okay, that means the distance between the wall and the ladder on the ground. And let's say this height is y. So 4 meter per minute is if the ladder slide down the wall. So dy dt is given as minus 4 minute per 5 meter per minute. Why we have negative here? Because the distance is decreasing. The length of y is decreasing. So the question is find how fast is the foot of the ladder moving. So we need to find dx dt when the top of the ladder is 5 meters, so when y equal to 5. So we need to find this. Okay, now the second step is to find the relation between y and x. We can see here that y and x is related by theorem Pythagoras. Okay, we know that the length of the ladder is given as 13 meters. So this is the length of the ladder. Okay, by theorem Pythagoras, x square plus y square equal to 13 square. By applying implicit differentiation, we get d dt x square plus d dt y square equal to d dt 13 square. Sorry, this is 13 square. Okay, now let's find the derivative for each term. This is 2x dx dt plus 2y dy dt equal to 0. And we know that dx dt equal to, okay, we solve this algebraically, you get minus y over x dy dt. Okay, now we need to find dy dt. How to find dy dt? Okay, by theorem Pythagoras, if we have this triangle with the length of hypotenuse is 13 and y is 5, this one should be 12. Okay, so dy dt here minus y over x, dy dt is given in the information, which is equal to minus 4. Okay, then you can insert the value of y, which is 5. The value of x is 12, and you need to multiply with minus 4. This one also minus here. And we solve this, we get 5 over 3 meter per minute. So this is the answer. Okay, that's end our discussion about related rates and rates of change. Hope you can learn well. Bye.